Assalamualaikum brothers and sisters. So hari ni I'm going to finish off chapter 1. So last week we already covered your voltage amplifier. So today I'm going to finish off with current amplifier. Okay. So this is the current amplifier block. Okay, so it has the input side and the output side. So if you compare with voltage amplifier that we learned last week, okay, voltage amplifier pun ada input side and output side. Okay, so the input side dia similar lah. Okay, ada Ri, and this one also ada Ri. Tapi kat voltage amplifier dia refer the voltage lah, VI or V in. But for your current amplifier, they label the I in. Okay. But the important part is the output side. Okay, so if you look at the voltage amplifier, so the AVVI is in series with your R0. But for your current amplifier, the current source is connected in parallel with your R0. And again, the labeling of the parameter for your voltage amplifier is V out, and then this is the current I out. Okay. So that is the introduction lah on the structure. So last week I have informed to you that AV is referred to as the open circuit voltage gain. Okay, open circuit voltage gain. And why is it called open circuit voltage gain? Because AVVI, okay, will be equivalent to V out, okay, when the output terminal is open circuit. Right? So basically what happened is that when there is no, okay, I'm gonna delete this. When there is no load here, okay, it's open circuit. So current would like to flow lah kan, but the current cannot flow because the circuit is not complete. Okay, so because of that there is no current flowing through your R0, there is no voltage drop, so V out equivalent to AVVI. Okay, when the output terminal is open circuit. Okay, however for your current amplifier ni, right, it is referred to as short circuit. It's called short circuit current gain. Okay, so why is it called short circuit current gain? Okay, so it is called short circuit current gain because AIII, okay, AII in lah ya, will be equivalent to I0, okay, when there is a short circuit. Where is the bar ni? When there is a short circuit here at the output terminal. Okay, so basically what happened is that the current AII in ni, okay, will go through this short circuit path. Alright, so instead of going through this R0, okay, it sees a short circuit, so AII in will go through that short circuit. So that when that happens, I0 ni equivalent to AII lah. Right, so this happens when there is a short circuit at the output terminal. When there is a short circuit at the output terminal. Alright, so that's your current amplifier. Okay, so basically now if you go to the next slide, let me wipe this off. Alright, okay, so this slide in the question, it says the output short circuit current. Okay, so similarly, okay, last week I defined the open circuit voltage. Okay, so when we read this open circuit voltage, we are referring to a VI. Okay, so similarly, if we are talking about the short circuit current, okay, so when you are talking about the short circuit current, this term, okay, basically when you are referring to current amplifier, short circuit current is referring to AI, okay, I in, okay, I in. Okay, so in this question, what is given? The output short circuit current of a current amplifier. So what is given is the AI, II, right? So that is what given to you. Okay, you are given AI, II, which is equivalent to 255 milliampere. Okay, so and then the question proceed to give you the current gain. So the current gain is minus 50. Don't worry about the minus too. Okay, because gain can be minus and gain can also be positive, right? So you are given AI I in equivalent to 250, and then you are given what is AI. So what you need to do is just divide and you will get what is the input current. The question asks you what is the input current of the amplifier, right? So this is just to introduce you on the terms for your current amplifier, yeah? Okay. Okay, so let's proceed with the next example. So in this question, you are given the short circuit current gain, okay, which refers to AI. Short circuit current gain is AI, and then output resistance is referring to your R0. Okay, so the short circuit current gain AI is 30 and R0 is 2.5 kilo ohm. So the question asks, determine the output voltage. Output voltage is V out. So the question didn't show to you where is V out, okay? But we know that this is your output terminal, okay? Because your current I out goes through this terminal, okay? So when the question asks, determine the output voltage, determine the output current, it's definitely referring to the output terminal, whatever is connected at this output terminal. Okay, so back to the question. It stated that the output is connected to a load resistor, okay, 450 ohm. Okay? Okay, so back to the question. This is the output terminal, alright? So the input current is given to be 0.5 milliampere. So this is the input current. So the first step is calculate the value of the short circuit current AI, I in. Why you need to calculate this value is because this is the current source. Okay, so the current source, and then it will split to have a current flowing through here, okay, flowing through your R0, and then you have the I out current. So this is the node where AI, I in will split, right? So this is quite simple for you to do, right? What you need to do is just multiply AI and I in. So AI is given as 30, right? So you just need to multiply. Okay, so AI II equivalent to 30 multiply with what is I in? It's 0.5, okay? And you will get 15 milliampere. Right, so you get, you will get 15 milliampere. So take note on the unit of the current. So the current is given in milliampere. So make sure that your answer is also in milliampere. Okay. So the next step says use current divider to calculate the output current. Okay. So for your voltage amplifier, you use voltage divider. So for your current amplifier, you're going to use current divider. So current divider is normally used when you have a current source, or you know the main current, okay, and the current is going to be split between two resistors that are in parallel. So basically, let's say if I have two resistors R1 and R2 that are in parallel, So if I want to find the current R1, okay, the numerator will be R2. They are the resistor lah. So same thing, if you can see, R0 and RL are in parallel. Okay, I want to find current I0, which is the current flowing through your RL. So the numerator will be, okay, so this part will be R0. Okay, so the bottom part will be the sum of R0 plus RL. Okay, so when you calculate I0, so now you know what is the current. So the last step is just you multiply I0 with RL to get the voltage at the output. So the output is here. So you want to find what is V out. Okay, so you just use Ohm's law. Okay, I0 multiply with RL. Okay. Okay, so this is the another example, but it's a bit more tricky because you are not given the schematic. You're not given the block diagram of your current amplifier. Okay, so you are given the short circuit current. So short circuit current is AI, I in. It's 100 milliampere. The input is connected to a signal source and the voltage is 10 volt. Its resistance is 3 kilo ohm. And then input and output resistance of the amplifier. So you are referring to Ri and R0. Okay, 1 kilo ohm and 100 ohm respectively. Okay, so you can see that there are three parts. The first one is draw the schematic. So draw the schematic means the block diagram. Okay, the input terminal side and the output terminal side, how it looks like, including the source, including this voltage source. And then calculate the short circuit current gain, meaning you are going to calculate AI, and as usual calculate the output current and voltage. So these two parameters are at the output terminal. Okay, and there is a load 25 ohm. This is your RL. Okay, so let's look at the solution. Okay, so the first part is for you to draw the schematic. So the schematic is this part. Okay, alright, this is your current amplifier. So the input side has Ri and then the output side has R0. Yeah, so the one that might be difficult for you to realize is the input signal. So this is your input signal. Okay, so this is your Vs. Okay, so this is Vs, voltage source. Okay, and this is your Rs, its resistance. Okay, so the term says that its resistance. So the voltage source is 10 volt and its resistance is 3 kilo ohm. So this is how your schematic should look like. Okay, so this is part A. Okay, so now for part B, the question asks you to calculate what is the current gain. Okay, the current gain is for you to calculate what is AI. So the question gives you that AI I in, the short circuit current, okay, is 100 milliampere. So what it means that when there is a short circuit here, okay, so the current AI I in equivalent to I0 will be 100 milliampere. So that's what it means. Okay, right. So basically, when AI I in equivalent to I0 equivalent to 100 milliampere because of this short circuit. So now the question is you need to calculate I in. Okay, because you can just divide 100 milliampere over I in to get your AI. So this is your I in at the input side. So you need to do KVL. So as you do your KVL here, just do your loop here. Okay, so you will get 10 over 4 kilo ohm, and you will get, I think it's 10 over 4 is 2.5 milliampere. Okay, so you're gonna get 2.5 milliampere. So then you can divide and you will get AI equivalent to 40. Remember, for gain there is no unit. Okay, no unit, right? So The last question says that what if I have load at this terminal. So now I have a resistor. So let me just draw, for example, this is a resistor and the value is, I think it's, what was it, 25 ohm, right? Okay, so now this terminal is connected to this resistor. Okay, so your AI will always be 40, and your I in, because you did not change anything at the input side, it will always be 2.5 milliampere, right? So again, you're going to use the current divider, and at the output side, just use current divider to find what is I0. Remember, the question asks for two parameters. The first one is I0, and the second one is the voltage, the output voltage. So again, the output voltage is just using Ohm's law, which is the voltage across the load. This is your RL, kan? Okay, right. So first thing, we know that the short circuit current is 100 milliampere. Okay, right. So you don't have to worry about this anymore. Just use current divider, current at load resistor. So you want to know the current here. So the numerator will be R0, 100 ohm over 100 plus 25. Multiply with your current source, 100 milliampere, you got 80 milliampere. Then don't forget Ohm's law, which is you multiply I out with RL and you get 2 volts. So that is a solution for this example. Okay, so next is just transforming your voltage source into your current source. So this is what you have learned in your circuit, kan? So if your voltage normally is in series with your RS and your current source is always in parallel with your RS, okay, and normally they will have the same resistor lah. Okay, but how do you get IS and how do you get VS, kan? So I know that if I want to get IS, right, I will divide VS over RS, the Ohm's law. And also if I want to get VS, I multiply IS with RS, okay, to get the voltage source. Okay, so in this example, right, in this example the question is a voltage amplifier, okay, but I want to calculate the short circuit current gain and given AV 127.9. The other parameters is R0 and Ri. Okay, so if I based on the source transformation, okay, so if you look at the next slide, okay, you need to transform this into the current amplifier, the, how to say, into current source basically. Okay, so you can see here what I did was, this is your voltage amplifier part just now. Okay, so remember when we want to transform into current source, voltage over R0, okay, you need to divide. So this is what I did. Okay, so voltage over R0, you will get current. This is your current. Okay, this is I. So, but I in, okay, so I in is at the input side. So you need to calculate what is I in. So VI over RI is your I in. This is also Ohm's law. So you can see here, this is Ohm's law. Okay, so that's what you are doing that. Alright, so I just replace this into I in over there. So you can see here, and eventually you will be able to, okay, you will be able to cancel VI. Okay, cancel VI here. Right, and you are left with AI equivalent to AV Ri over R0. So you manage to get the value of the current gain by simply using source transformation. Okay, so just to make you realize that it's just using Ohm's law. Okay, so whatever it is, it started using by using a simple rule called Ohm's law. Alright, so that's the end of chapter 1. Alhamdulillah. So I hope that you can just keep on going back to this presentation. Sorry that maybe it's not as smooth as I would like. I'm pretty sleepy at the moment. So I see you guys in the next video. I suppose I'm going to talk about the next chapter, chapter 8, operational amplifier. Okay, Assalamualaikum.